So the next presentation is by Dr. Aditya Kolacham. He is Assistant Professor at IIT Madras at the Department of Humanities and Social Sciences. He completed his integrated MSc from IIT Kharagpur, postgraduate diploma in management from IIM Ahmedabad, and PhD from IIT Bombay. That's very heavy profile. Principal investigator at Center for Indian Knowledge Systems. He has published quality research and disseminated the findings through various academic seminars and conferences. He has been awarded for excellence in PhD research and Young Historian of Science Award from the Indian National Science Academy in 2019. His research interests include mathematics, astronomy in India, scientific literature in Sanskrit, and manuscriptology. So he will be presenting. So this also becomes a continuation of what presentation we had earlier. He would be giving a presentation of overview of Madhva's Lagna Prakarana.
Yeah, Madhva is
Madhva. Is it?
Oh. I think even Amartya Sen had this confusion. So,
so I'm spared. Over to you.
I think it's appropriate to say good afternoon, everyone. Now, almost. So, firstly, let me thank the organizers for inviting me to this talk. It's a pleasure to be here. I'm going to talk on Madhava's Lagna Prakarana. So, I'll give a brief introduction, which will lead up to understand Madhva. We first need to understand a little bit of history. After that, I'll give a brief introduction to Madhva and Lagna Prakarana itself. Then I will discuss one problem in spherical trigonometry which has been solved in the Lagna Prakarana. Then I will briefly discuss a few important results given in the text and then conclude with some observations. So Professor M. D. Srinivas also showed us a list of some of the important astronomical texts in the country. So generally when this is enumerated, we start with Aryabhatiya. We know that there are accounts of at least 18 Siddhantas before Aryabhata himself. But Aryabhata, I think once Aryabhata gave his Siddhanta, it sort of became the canonical Siddhanta, and vast majority of the country accepted that as the foundational text for astronomy in India. Even his critics had to critique him. I mean, whether you were from his school or not from his school, everyone had to, they could not ignore Aryabhata. They could not ignore Aryabhata. So we have some other important texts are Pancha Siddhantika of Varamihira, Aryabhatiya Bhashya of Bhaskaravan, which helps us understand Aryabhata, Brahmasputa Siddhanta of Brahmagupta, where, you know, in some certain instances he has critiqued Aryabhata. Shishyadhi Vriddhida Tantra of Lalacharya, the name itself is very interesting. The text which enhances the intellect of the Shishya or the student. Mahasiddhanta of Aryabhata to Siddhanta Shekhara, Siddhanta Shiromani of Bhaskara to. And then we have the topic of this talk, Lagna Prakarana of Madhva, 14th century. It's a 14th century text. Some other important texts from the Kerala school, Gola Deepika of Parmeshwara, which again Professor Srinivas mentioned briefly, Tantra Sangraha of Neelakantha. Many other texts. In this Sanskrit astronomical tradition, perhaps the last major text is what is known as Siddhanta Darpana by Chandrasekhar Samanta, a Orissa astronomer in the 19th century. I think the second half of the 19th century, sometime maybe 1869. 1869 is that is the last known major work in Siddhantic astronomy in India. Improved means he seems to have incorporated certain I mean, again, I'm no expert on that particular text. From whatever generally I know, he has incorporated certain what we can consider as aspects of modern astronomy into that.
He made some observations himself.
Proved that. We brought in the 4 lunar corrections. That is not necessarily modern.
It's not necessarily modern, yes. It's not necessarily modern. So to understand the contributions of Madhava and Lagna Prakarana, I just briefly want to talk a little bit about Aryabhata before I jump to Madhava. Why I didn't mention, this is not an exhaustive list. A few famous astronomical texts.
KTP not in the Indian Siddhantic tradition, perhaps. Yeah.
Whether any specific reason to specifically say that Siddhanta Darpana is the last.
Old Siddhantic.
Okay. Yeah. Let's discuss. Okay. It's a little. Can you just go to the next slide? Okay. So Aryabhata, I will not give too much. So there are 2 invocatory verses. So Aryabhata has written 2 major works, Aryabhatiya and Aryabhata Siddhanta. The Aryabhata Siddhanta is now lost. Only portions of it are quoted in subsequent texts, but only the Aryabhatiya survives with us today. And it has 4 padas. Aryabhatiya has 4 padas. In the Geetika pada, there are 2 invocatory verses. The first is to the Geetika pada, the second is to the Ganita pada. So in the first verse, he pays obeisance to Brahma, and then his name is found there. Aryabhata Trini Gadati Ganitam Kalakriyam Golam. So he's laying out the contents of the text. You also find his name in the invocatory verse of the Ganita pada. Aryabhata Stvina Nigadati Kusumapure Abhyarchitam Jnanam. So he says that I'm setting forth the knowledge honored in Kusumapura. So the commentator Bhaskara 1 has identified Kusumapura as Patliputra, so which you know as modern day Patna. So it appears that Aryabhata did his education there. But there is also, he's referred to as Ashmakiya, and so K. Shukla says, this Ashmaka kingdom is considered to be on the banks of the Godavari, and so Aryabhata may have been originally from the banks of the Godavari and went to Patliputra for his studies. So to my students in IIT Madras, I give the example that just like you have come to Chennai from all over India, Aryabhata went to Patna. One important verse in the Aryabhatiya, which plays a very important role in the chronology of India, is the dating of the text. Shashtakdanam Shaktiryada Vidita Strayasti Vibhavadaha Yadhika Vimshati Rabdas Tadeha Mama Janmanotita. So he's stating that he was 23 years old when 3600 years of the Kali Yuga had elapsed. So that puts the date at around 499 CE. So Kali 3600 corresponds to 499 CE, and if he was 23 years old, then he was born in 476. This particular verse and the Aihole inscription in Karnataka also gives the similar date for the start of the Kali Yuga. So this is one view of the start of Kali Yuga and the dating of Mahabharata, etc. There is of course Varahamira, which is a slightly different date, and I will not get into all that. We also, in the last verse of the text, he gives the name Aryabhatiyam Namna Purvam Swayam Bhom Sadanityam Sakrutayushoho Pranasham Kurute Pratikanchikam Yosya. So if you find fault with it, bad things will happen to you. So there are some interesting concepts. This is just to introduce the concept of the some important concepts which are required to understand Madhava's Lagna Prakarana. So what is the situation of the Earth, its constitution and shape? So Aryabhatiya states, Vritta Bhakanjara Madhye Aksha Pariveshtitaha Kamadhyagataha Mrujjala Shiki Vayumayo Bhugolaha Sarvato Vrittaha. So it is It's the globe of the Earth stands supportless in space. Okay, so this is I mean, it doesn't state directly, but at the center of the circular frame of asterisms, so in the center of the Bhagola, what is called, and is surrounded with the orbits of the planets. It's made up of water, earth, fire, and air, and is spherical. Sarvato Vrittaha. So then he also compares the earth to the Kadamba flower. Yadvat Kadamba Pushpa Grantihi Prachitaha Samantadaha Kusumaihi Tadvadhi Sarvasatve Jalajayi Kalajayisya Bhugola. So he's saying that the earth is like the Kadamba flower and it is surrounded on all sides by terrestrial and aquatic animals. So, so there is a very clear concept of spherical earth situated at the center of the asterisms, which is called as the Bhagola, which in modern or in modern terminology, in English they use the celestial sphere. So the celestial sphere is critical.
Not even Bhugola outside the Bhugola. Tadvadhi Sarvasatve Bhugola.
No. I mean, it is. I mean, like on the surface of the earth.
One Kadamba, all Kadambas
Just like just like the Kadamba is covered by the blossoms on all sides. Similarly, it's the earth is surrounded by all these creatures. On the surface, I think that's what you have to understand it. I mean, that it's on the surface of the earth.
One minute. Can I say in the second line, that first line is clear, Kadamba Pushpa Granthi, that the midst of Kadamba Pushpa, it is surrounded by all flowers. But the second line, what you said is, it is Tadvat, that is Adhi, the next word is by water.
No. Tadvadhi.
No. Tadvadhi, no. Tadvadhi, yeah, you can say. And then Sadhu Sattva Jalagi.
Okay. Aryabhatta has made an important observation regarding the motion of the stars. So there is a famous verse in the Aryabhatta. Anuloma gatir naustaha pashtyachalam vilomagam yadvad achalani bhani tadvad samapaschimagani lankayam. So Lanka is a technical term which they use in Indian astronomy to refer to the intersection of the prime meridian and the equator. So the 0, 0 point. So that is the term they use, Lanka. So the intersection of the prime meridian and the equator. So what Aryabhatta is basically saying, he is making use of analogy. He says, just like when you are going in a boat, the objects on the banks appear to be moving backwards. So he uses this concept of relative motion. Similarly, the stars appear to be rising in the east and setting in the west. What does that mean? That actually it's not the stars that are moving. Kind of gives you an idea that he had, it's that the earth is rotating and not the stars are moving. So, in fact, this was quite a revolutionary idea, which was even criticized by Varahamihira and Brahmagupta. This guy, it's the stars are stationary and the earth is rotating. It was quite revolutionary. I'm sorry, the slide is slightly, but the text is small. He also talks about 4 cardinal cities. So he says, when it is sunrise at Lanka, Udayo yo Lankayam, Swastamayaha, Savitureva Siddhapure, Madhyano Yavakotyam, Romaka Vishaya Ardharatram Syat. So if you consider 4 points on the Earth's equator, which are 90 degrees apart, so he says, when it is sunrise at Lanka, it is sunset at Siddhapura, midday at Yavakoti, and midnight at Romaka. So these are points which are 90 degrees apart. So obviously that's how it will be. And he also very clearly gives the positions of Lanka and Ujjain. Sthala Jala Madhya Lanka Bhukakshaya Bhave Chaturbhage Ujjaini Lankayah Tat Chaturamshe Samottaraha. So from the center of land and water. So basically, these are the North Pole and the South Pole. So in between them is Lanka. So basically, that will be the equator. So the Lanka is the equator, and the Ujjaini is at a distance of further 1/4. That means 1/4 of 90 degrees is 22.5 degrees. So it's basically stating that Ujjain has a latitude of 22.5 degrees. This he doesn't state it directly, but this indirectly also tells that the prime meridian is that which passes through Ujjain and Lanka. In fact, a much more explicit statement is given by Bhaskaravan in the Laghu Bhaskariya. Lanka Vatsyapura Avanti Sthaneshwara Suralayan Avagapya Sthitareka Deshantara Vidhayini. So, in fact, so he is stating that the line passing through Lanka, Vatsyapura, Avanti, Sthaneshwara, and Suralaya is the prime meridian. So, Lanka, I said, is the intersection of the prime meridian and the equator. So, it's the 0 latitude, 0 longitude point. Vatsyapura, there is people have 2-3 places have been proposed to be Vatsyapura. Mainly in Karnataka, but one interesting, it's Badami has been one of the places which has been proposed to be Vatsyapura. It seems to be having, because it's Agastya Kshetra and there is some very interesting, so it could be Badami in Karnataka. Avanti is of course Ujjain. Sthaneshwara is a place nowadays known as Thanesar in Haryana. It's not very far from Delhi. So, so that seems to be the proposed. In fact, in the Surya Siddhanta, the prime meridian they state is passing through Rohitaka. So, Rohitaka is, of course, Rohtak in Haryana today. So, these are all nearby places. And there is also, in fact, even yesterday, one of the questions was the Ujjain Mahakal is the name a coincidence? And some people do speculate that that Jyotirlinga is actually the marker of the prime meridian, and the name itself is has some significance.
What is the latitude
of Mahakal? No. In fact, Brahmagupta has stated that.
What is the current?
I didn't check that, sir. I didn't check that. No, but it is in Ujjain only, so.
Not very.
Post Aryabhatta also, there have been some interesting statements which have been made. So, in fact, for instance, this statement of Lalla, as Professor Srinivas was also hinting, shows some skepticism towards some of the Puranic descriptions. So, Kamatadivi Rudhrita Mahiyadi, Tekena Judha Nabhastita, Ate Esham Viyati, Sthitir Shitibolaskyatu Kena Varyate. So, he is asking if the earth is supported by tortoise and other things, then by whom are they supported in space? And if they can remain unsupported in space, who prevents the earth from remaining thus unsupported? Bhaskara 2, this is nothing to Akrishta Shaktistami. So, this is an interesting statement he makes that the earth has a power of attraction, and that is why the objects in the sky are falling towards the earth. So these are a few of the interesting statements. The whole point why I use this to lead up to Madhva and the Lagna Prakarana is that there was a clear understanding about the spherical nature of the earth and this model of a celestial sphere. So all these planets and stars are rotating on the surface of the celestial sphere, and we are at the center of the sphere and we are observing the motions of the stars and the planets. So we will see how that feeds into this. So I'll just give a brief introduction to Madhva. So Madhva is known as the founder of what is known as the Kerala School of Astronomy and Mathematics. So Madhva was a legendary scholar who gave many important results. So he lived in a place known as Irinyalakuda near Cochin in Kerala. So in Sanskrit, it is Sangamagrama, and people who know Malayalam have told me that Irinyalakuda can be interpreted in a similar fashion as Sangamagrama. So at the confluence of the ocean. And he is referred to as Golavit. Golavind is literally the knower of the celestial sphere. And in fact, if you look at Lagna-Gokarna, it will become very clear the kind of projections and how the comfort with spherical trigonometry and the projections is mind-boggling. So the known works are Sphuta Chandrapti, Vedmaroha, Aganita Grahachara, Chandravakyani, Madhyamanayana Prakara, Mahajyanayana Prakara, Lagna Prakarana, Golavada. These are some of the works which are attributed to Madhava. So by and large, they have not been studied in depth. Okay, some basic studies have gone, and by and large, they are actually much of what we know about Madhava is only through the works of his disciples. So in the Kerala school, everyone keeps glorifying Madhava and saying that Madhava has given this result, Madhava has given that result. We have even the works of the Kerala school, very few have been studied, but whatever few have been studied tend to attribute many results to Madhava. So what are his important contributions? He has given an infinite series for pi, and then the corollary will be the tan inverse function. And now the sine and cosine functions, he has given the infinite series. He has also introduced innovative techniques for astronomical computations. And all this mainly we know only through the works of the study of the disciples. So there is actually a huge pressing need to study the works of Madhava himself. And actually for my thesis, my PhD, I did was on the Lagna Prakarana. So many of the other works also need to be studied in that. So what is this Lagna Prakarana? It's an astronomical text dedicated to the computation of Lagna. And I'll come to what Lagna is. And it consists of 139 verses divided into 8 chapters and is composed in 18 different meters. So like many other scholars in the Indian mathematical and astronomical tradition, Madhava was also a poet par excellence. It gives the exact value of Lagna, unlike earlier texts. So up till Madhava, they were using a way of computing using certain interpolations, which gave a fairly good estimate, but nevertheless an approximate result for the Lagna. And so Lagna Prakarana is, as far as we know, the first text where we get a precise computation of the Lagna. And what is very interesting is this text is dedicated to the computation of the Lagna. So it is quite a unique text in that sense. Many of the astronomical texts in India, they tend to be of a wide range. They discuss many topics. What Madhava has done is he has taken one topic and has said 8 chapters, 139 verses. He gives about a dozen ways of computing Lagna, all precise and all using a different approach. So it speaks of not only his astronomical genius, but also his mathematical genius and some just raw love for the subject. So it can be done this way, it can be done this way. He starts with things which you can never imagine will be involved in Lagna computation, and he shows how you can compute Lagna using that. It's a fascinating text. And to do this, he actually ends up introducing a number of very important relations and additional astronomical parameters, new parameters and relations known as such as Prana Kalantara, Kala Lagna, some what are known as Drukshepajya, Drukshepakotika. Some of them have been discussed by earlier astronomers, but some of them are also new. So what is the Lagna? So the Lagna is that which adheres, touches, intersects. That is what the Lagna is. And this in astronomy, this is typically used to a point on the ecliptic which is in the point on the ecliptic which is in conjunction with another circle. So it is basically the intersection of two great circles on the celestial sphere. Generally, one of those circles is the ecliptic. And there are various kinds of Lagna, but most commonly it refers to what is known as Udaya Lagna or the rising ecliptic point. So what is the ecliptic point on the horizon? So, and so this can either be the exact longitude of that point or the Rashi in which that point falls. So it can be either of those things. And why is it important? It is important for certain astronomical computations. For instance, in the eclipse computations, they make use of the Lagna. It is also has great socio-religious purposes. I think most of us would have encountered the term Lagna more in terms of some Janma Kundali or wedding invite, particularly in South India. That's where we typically tend to encounter this term Lagna. So it appears to have had a social religious significance as well, the computation of the Lagna, because the astrological traditions assigned some properties to various different Lagnas. So let's visualize what is the Lagna. So this figure depicts what is known as the celestial sphere. So this P is what is known as the celestial pole. Okay, so I have not shown the other end of the pole, but it is on this axis that which the celestial sphere appears to be rotating, as described even in the Puranic texts and whatnot. And north, east, south, west, this will be the 4 cardinal directions. In fact, the first problem in astronomy is to compute the are there and how they can be corrected. Yes. So this red line, this red circle that you see, what is known as the ecliptic, that is the circle on which the sun appears to be rotating around the earth on an annual basis. And this brown circle is the celestial equator, basically the projection of the Earth's equator into the in purely mathematical terms. This is a problem in spherical trigonometry. The computation of Lagna is the computation of this arc gamma L. I want to know. So generally the ecliptic longitude, the sun's longitude, any other body's longitude is measured along the ecliptic. From this point gamma, they do what is known as the Sciana longitude. So I want to compute what is gamma L. So this is the problem, and it is a non-trivial problem in spherical trigonometry. There are some easy problems in spherical trigonometry, but computing this gamma L is a non-trivial problem in spherical trigonometry. So the genius of Madhava is in actually solving this problem, and that is why he has been able to give a precise relation for Lagna, where the earlier astronomers, I would say, were not. Perhaps they might have known some techniques, but the interpolation technique has an advantage in that it has some simplicity and its ease of use is there. While Madhava has given precise relations, it may not be so easy to compute. So typically to solve a problem like this, you need to identify a spherical triangle in which you need, if you know at least 3 quantities, you can compute one of the unknown quantities. So the problem is it will not be very easy to identify a spherical triangle which will satisfy that condition. And that's why what Madhava basically does in Lagna Prakarana is he introduces a concept called Kala Lagna. So Kala Lagna is basically this arc gamma E. So you can think of it as the Lagna of the celestial equator, because the celestial equator is the on which you measure time. So that's why there's probably the intersection of the celestial equator and the horizon. He has called that the Kala Lagna, so which is nothing but the measure of this arc gamma E. He first shows how to compute this arc, and once you are able to compute this arc, then computing this gamma L becomes easy. So that's what Madhava has done. So perhaps okay. So before Madhava, there was certain interpolation they were using before Madhava. So they would compute what is known as the rising time of Rashis. So you know that gamma to R1. So this Rashi is a 30-degree segment of the ecliptic. So Mesha, Vrishabha, so on. Each 30-degree segment is a Rashi, and they have a very interesting way of computing the rising time of how much time each Rashi takes to rise. And so what they do, and again this is a very, very basic explanation, because you know how much time each Rashi takes to rise, you compute what is the time elapsed in the day. And you keep subtracting the rising times of the Rashis from the time elapsed in the day to get an estimate of which Rashi is on the horizon. That's what they were doing before Madhava. And this involves some interpolation and approximation, but it gives a reasonably okay result. So what did Madhava do? Okay, so this is the content of Lagna Prakarana. In chapter 1, he discusses concepts known as Prana Kalantra, Chara, and Kala Lagna. Chara is essential difference. So you can see that there are a lot of various kinds of terms here I have given you. Rashi Bhuta Lagna, Madhya Lagna, Madhya Kala, Madhya Jya, Drikshapadya, then Shanko, Drigati, Samalagna, Valana, Vishwachadana, Vishwannara, Ayananta Shanku, Paramakshiti Maudvika, so many concepts. In fact, see, the extent of the terminology employed actually gives us a clue as to how in-depth science is studied generally. If there is a limited terminology, then generally it's a sign that the science is not very fairly well developed. Whereas, the existence of a extensive, well-defined terminology, this paribhasha, just gives a clue as to how sophisticatedly it has developed. So just looking at this, it gives you a fair bit of clue that it's fairly sophisticated level of development has happened in this science, astronomical science. So what I will briefly show is one of the techniques given in the 5th chapter, which actually brings out the genius of Madhava. So he has given from chapter 2 itself, he has given every chapter discusses 2-3 different techniques of computing Lagna, which again speaks to Madhava's genius. And see, this is typical of someone who has very mathematically minded and who just derives joy from it. Okay, you have got one proof, but you want a more elegant proof. You want another way of approaching it. You want to take up a challenge. So you are telling me that this concept is not at all related to Lagna. I will show you how you can compute Lagna from this. Okay, so it is that kind of shows. And personally, I have been convinced why Madhava has been called Golavid after studying this text. So this is a little bit about the source materials. Many of these texts, in fact, the Lagna Prakarana would have been probably lost to us if not for Professor K.V. Sharma, who saved the manuscript by actually he went to the Kerala Oriental Manuscript Library and jotted it down in his diary because he knew when he saw the manuscript that it's crumbling. And it is mainly through his notes that we have been able to study the text. And that's why it's in his honor that we have the Professor K.V. Sharma Research Foundation and whose president Professor Sriram is. So we owe gratitude to Professor Sharma, Professor Shukla, who have done Saraswati Amma, who have done amazing work in preserving our heritage, scientific heritage. Okay, how much time do we have? 12:45. Okay, I'll try to wrap up. So this is a fairly technical discussion. What I will do is I will skip most of the technical discussion. So basically, he is showing how to compute what is known as Vishwannara and Ayananta Shanku. Okay, I will just give an overview. Vishwannara is the Shanku corresponding to this Vishwa. So basically, the gnomon corresponding to the equinoctial point. And Ayananta Shanku is basically the gnomon corresponding to the solstitial points. And he shows how this, once you compute the values of these gnomons, how you can easily compute the Udaya Lagna. Let me just only focus on the verse rather than getting into the technical aspects. You can see that it's a fairly complicated picture, diagram, and the mathematical formula is also not simple. But you will not, the verse will not scare you away. Okay, so this is an Indra Vajra. Lamba hata kala vilagna dojya vyasar bhakta vishwannaram syat antyadyu jiva hata kala lagna koti gunadya tribhamor vikaptam. Okay, so very complex. This is the genius of again the Indian scientific tradition. Is that extremely complex mathematical, astronomical, even other sciences, linguistics, Ayurveda, metallurgy, they tend to give extremely complex ideas and sublime poetry. Sublime poetry. They were all of them were not only great scientists but artists as well. The all-round, well-rounded individuals. So it's a very beautiful way of expressing complex relations. I will just point out one interesting mathematical aspect here. He talks about Tallambhagatam Palamorvikante Krantyorvade Karki Mrugadi Katva. So he says that this relation changes Karki Mrugadi Katva depending on whether it is Karki or Mruga. Karkyadi or Mrugadi. So what does this mean? I will just show you the relation. I will just show you. I will skip all the complicated spherical trigonometry and I will just show you the relations. So he says that the Shanku, the formula will be this when it is Karkyadi, and the formula will be this when it is Mrugadi. You can see that the formula, the terms are the same except for the plus or minus sign in the expression. So, we all know. So this is actually an interest. Huh?
What is alpha?
Alpha is Kala Lagna. Alpha is Kala Lagna. So the Kala Lagna can vary from 0 to 360 degrees.
On the left side, then what you have?
This is the height of the Shanku, Ayananta Shanku.
Oh, I see.
That is the height of the Ayananta Shanku in terms of the Kala Lagna. So this cos epsilon and cos phi, epsilon and phi, obliquity and latitude will be within 90 degrees. So within 90 degrees, cosine is always positive. But this Kala Lagna can vary from 0 to 360 degrees. So we know that cosine is positive in the first and fourth quadrants and it's negative in the second and third quadrants. So this Karki Mrugadi Tattva is actually indicating the change of sign in the cosine function. So Karki refers to it's the fourth Rashi. So from 90 degrees onwards. And Mruga is the 10th Rashi. Mruga is Makara. So it is the 10th Rashi. So that is from 270 degrees onwards. So from 270 to 90, he's saying you applied positively. From Karkadi, you applied negatively. So again, it's a beautiful mathematical concept which simply is just Karki Mrugadi Tattva. So it's a beautiful way of presenting the relation. So once you compute that Ayananta Shanku, it's very easy. You just need to compute this arc. It will be some basic spherical trigonometry will take you to the relation. So I'll perhaps skip that. And so this is again the visualization. He talks about it being in different quadrants, and when the Kala Lagna is in different quadrants, basically the orientation of the ecliptic is changing with the celestial equator, and that's why that adding and subtracting can be even checked visually. It's not just an abstract mathematical concept, but we can physically visualize and confirm that is how it will be. That's how it will be. It's quite amazing. So what are the important contributions? Precise results for the Udaya Lagna. Perhaps the first text gives the exact result for the Udaya Lagna. Discusses multiple approaches to the same problem. It also gives expressions for Prana Kalantara and Jijya, other important astronomical parameters. New relations and interesting application of Chara, which is the essential difference, which is required to compute the length of the day and the time of sunrise. The concept of Kala Lagna appears to have been introduced first in the Lagna Prakarana, which has been subsequently used in many other Kerala texts. Yeah. So it's a very well structured text. So each relation feeds into the next. It's not haphazard. So each math, just almost like one would write a mathematical work today. You have equation 1. So from equation 1, equation 2 implies equation 2 implies equation 3, so on. It's a very, very well structured and organized text. Introduces a large number of synonymous terms. So this is because of the need of the metrical constraints of you need to have a lot of synonymous words. So author's passion for mathematics and astronomy, this we have seen through the multiple relations for the same, multiple approaches to the same problem. And the very sophisticated spherical trigonometry actually indicates why he was known as Golavil. And it also indicates the proof of prevalence of strong analytical traditions in Kerala. In fact, it's not part of this talk, but the Madhava and the Kerala school is also credited with the origins of calculus in India. So that's another whole another talk. And we can clearly see the impact on later works such as Pancha Sangraha Karna Paddhati Ganita Yukti Bhasha of the Kerala school. And it's an important text which furthers our understanding of the development of astronomy in India. So, thank you. That is my.
I think we got a very systematic presentation of the Madhava's Lagna Prakarana based upon Aryabhatta's work, and then we very systematically put down what are the contributions made by Madhava in the Lagna Prakarana, you know, the concept of Kala Lagna and the computation of Uday Lagna. So I think it was very systematic. Thank you so much for this contribution.